Hi, welcome back. Can you evaluate this expression? The first thing that many of you may be wondering is, what are these? Because they're not brackets. Well, these are mathematical symbols that mean floor. And floor just means that we round down. So if the answer to this was 127.5, then the floor symbols just mean that we round down to 127. Okay, so now that you know that, how are we going to evaluate root 2 plus 1 to the power of 8? Well, we could just expand this out, but that would be a bit long and laborious. So this is a much more elegant solution. Let's set A equal to root 2 plus 1. And we'll set B equal to root 2 less 1. So A times B equals root 2 times root 2, which is 2, root 2 times minus 1 and root 2 times plus 1, well, that cancels out, and 1 times negative 1 is negative 1. So this actually equals 1. And A plus B equals, well, the 1's cancel each other out, and we just get 2 lots of root 2. Now, what does A plus B all squared give us? Well, it gives us A squared plus 2AB plus B squared. And if we isolate the A squared plus B squared, this equals A plus B all squared less 2AB. All I've done here is just rearrange this equation here. And since we know that A plus B is 2 root 2, then we can just square 2 root 2 and we get 2 2's are 4, and root 2 times root 2 is 2, less 2 lots of AB. AB is 1, so this is just 2. Therefore this equals 6. So A squared plus B squared equals 6. Now let's take A squared plus B squared and square all of it. So this is a similar process to the above. So A squared squared is A to the 4. We then get 2 lots of A squared B squared plus B to the 4. And again, rearranging this to isolate A to the 4 plus B to the 4, we get that this equals A squared plus B squared all squared less 2 lots of A squared B squared. And again, we know what the terms on the right hand side evaluate to. A squared plus B squared, well, we know that equals 6, so this is 6 squared, less 2 lots of A squared times B squared, well, that's just this squared, so this is just 1 again, so it's 2 lots of 1. So this equals 36 less 2, which is 34. And finally, we're going to have a look at A to the power of 4 plus B to the power of 4 all squared. This will finally give us our power of 8 that we're looking for. So again, expanding this out, we get A to the 4 times A to the 4, which is A to the 8th, plus 2 lots of a to the 4 b to the 4 plus b to the power of 8. And again, if we isolate a to the 8 plus b to the 8, we can rearrange this to get that equals a to the 4 plus b to the 4 all squared less 2 lots of a to the 4 b to the 4. And again, we can evaluate the right hand side because we know a to the 4 plus b to the power of 4, that equals 34. So this is 34 and it's squared, and that is less 2 lots of, well, again, we know that a to the power of 4 times b to the power of 4 is just going to be this raised to the power of 4, which is 1. So 34 squared is 1156. So 1156 less 2 is 1154. So how does that get us closer to answering this question? Well, we've just established that a to the power of 8 plus b to the power of 8 equals 1154. Now we're looking to find a to the power of 8, since a equals root 2 plus 1. But first, let's have a look at b. b equals root 2 less 1. So we can say that b equals, well, root 2 is about 1.4-ish, and we're going to deduct 1. So we can say that b has got to be greater than 0, but less than 1. And if this is true, then b to the power of 8 must also be greater than 0 and less than 1. Therefore, the only way that this equation will work is if a to the 8 is 1153 and b to the power of 8 is some fraction of 1. But we don't need to worry about what this fraction is, because we're going to take the floor of this expression and round down. Therefore, our answer is 1153. Did you get it? Did that approach make sense? I thought that was quite an interesting problem. A little bit different. I hope you like that, and I'll see you in the next video. But in the meantime, why not check out one of these? Bye.